You know that fiber optic cable that brings you super fast internet? Well, what if I told you that same tiny strand of glass could do more than just carry data? What if it could actually feel whatever it was touching? It sounds like something out of a sci-fi movie, right? But it's very real thanks to some incredible research from Mohammed Musaber Bilal and his team.
And it all really boils down to this one simple question. How on earth can a cable designed just to carry light suddenly tell the difference between water and alcohol? I mean, it seems impossible. But the answer is this really clever mix of smart engineering and some seriously cool physics.
So, how do you get started? How do you give a fiber a brand new sense? Well, the first part of the puzzle isn't about adding complicated new technology. Nope. It's about something much more direct, physically changing the shape of the fiber with a technique called side polishing. Okay, so on the left, you've got your standard fiber. It's basically a perfect little prison for light, designed to trap it inside so it can travel for miles without escaping. But on the right, well, that's where the researchers did something kind of radical. They polished one side completely flat, creating a tiny little window for that trapped light to finally peek out and see the world. And the level of precision here is just wow. It's mind-boggling. They create this D shape by shaving off the outer layer. That's called the cladding, until they are just 2 micrometers away from the core, where all the light is zipping along. 2 micrometers. That's thinner than a strand of spider silk. And that tiny gap is the key to everything. So, we've got our window, but how does the light actually feel what's on the other side? This is where we get into the really cool, invisible science that makes the whole thing work. It all starts with something that has a kind of spooky name, an evanescent field. You see, even in a regular fiber, a tiny bit of light energy kind of leaks out just past the core. It's not light you can see, it's more like an invisible field of influence. The best analogy is feeling the heat radiating off a stove without actually touching the hot surface. This invisible ghost field is what's going to do all the sensing for us. The second piece of the puzzle is something called the refractive index, or RI for short. Just think of it like an optical fingerprint. Every single substance in the world, air, water, alcohol, you name it, bends and slows down light in its own unique way. The sensor isn't really seeing the liquid, it's just reading this unique fingerprint. So you put it all together, and it's a really simple chain reaction. First, you put a drop of liquid on that polished window. Second, the liquid's unique refractive index, its fingerprint, interacts with that ghostly evanescent field. And third, that interaction actually changes how much light makes it all the way to the other end of the fiber. A different liquid means a different fingerprint, which means a different final signal. It's really that elegant. Now, of course, this all sounds great on paper, but you know how it goes in science. You have to prove it. So the researchers decided to test their idea in 2 completely different arenas: the virtual world of computer simulations and the real world of the lab. What they did was pretty clever. First, they built a complete digital twin of their sensor inside a computer. They used software to predict exactly what should happen to the light signal when they put different things on it, like air, plain water, or isopropanol. And then they went into the lab, built the actual physical sensor, and ran the same tests to see if reality matched their predictions. And here's what the computer predicted. It calculated something called transmittance, which is just a fancy way of saying how much light gets to the finish line. The computer predicted a really clear pattern. As the refractive index of the liquid goes up, from air to water to isopropanol, a little more light should actually get through. Just remember that clear upward trend.
And now for the moment of truth, the results from the real lab. And would you look at that? At the other end of the fiber, they have a detector that turns light into an electrical voltage. And it shows the exact same pattern. As they went from air to water to isopropanol, the output voltage just climbed and climbed, perfectly matching what the computer said would happen. The theory was a perfect match for reality.
So, with the simulation and the real-world experiment telling the exact same story, it was time to lay down the final verdict. And here it is, right from the researchers' own paper. They say the results are in good agreement. Now, in the world of science, that's a very humble, very understated way of saying, heck yeah, it worked exactly like we thought it would. This was the confirmation that their design was a solid, reliable way to sense different liquids. But it's one thing to know that it works. The next big question is, how well does it work? How sensitive is it really? Well, that all comes down to this one single number. So what on earth does this number mean? This is the sensor's official sensitivity.
Think of it like the volume knob on your stereo. For every little change you make to the liquid's refractive index, how much does the output signal shout back at you? A bigger number here means the sensor is way better at spotting even tiny, subtle differences between substances, which makes it a much more powerful tool.
And to put the cherry on top, they calculated this thing called an R-squared value, and it came out to 0.988. Now in statistics, a perfect score is 1. So what this basically means for us is that the sensor's response is incredibly predictable and rock-solid reliable. You can really trust its measurements.
Okay, so we've got a tiny, cheap, super reliable sensor made by just modifying an internet cable. But what's the big deal? Well, this is where we zoom out and start to see just why this clever little fiber matters so much.
Other fiber sensors do exist, but a lot of them are pretty complex. Some designs make you fill a hollow fiber with your liquid, others rely on fancy, expensive materials like graphene. The absolute beauty of this side-polished fiber is its simplicity. It's just glass and light interacting directly with the world. No fuss.
And that elegant simplicity unlocks a whole bunch of amazing advantages. Because it's just a strand of glass carrying light, it is tiny, it's cheap to make, and it's completely immune to any electrical interference that might mess up other sensors. Plus, it won't rust or corrode, so you could use it in some really harsh environments.
And that opens up a whole new world of possibilities. I mean, think about it. You could use this for real-time monitoring of chemicals in a factory, testing water for tiny amounts of pollution, checking the quality of your favorite soda, or even analyzing biological samples in a medical lab. All of that with a sensor that's barely thicker than a human hair.
So when you really step back and look at it, the idea is just breathtakingly simple. By just shaving a tiny window into a totally standard piece of glass, these researchers have unlocked a powerful new way to see the world. It really leaves you with one incredible question. What else are we going to be able to sense when an entire laboratory can fit on the tip of a single fiber of light?